Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's challenging level puzzle, and it's called Narrow Escape by Half-Baked Lunatic, aka David Workman. Here are the rules. We have normal Sudoku rules applied, which means in every cell in the grid, place a single digit from 1 through 9 such that there are no repeats in any row, column, or designated 9-cell region, which is a box in this case. We also have digits in cages must sum to the number in the corner of the cage, and digits cannot repeat within a cage. So, for example, if these three digits must add up to 19, so you could have something like 3, 9, and 7 here, and this would be valid. What you could not have is 5, 9, and 5 because you have a repeat in this cage, even though these digits add up to 19. So those are examples of how killer cages work. And finally, we have digits in cells separated by a black dot must be in a 2-to-1 ratio, and digits in cells separated by a white dot must be consecutive, and not all dots are shown. And these are called Kropke dots. So for example, if this were, say, a 2, this would have to be a 1 or a 4 to maintain the 1-to-2 ratio between them. If this were, say, a 6, this would have to be 5 or 7 to make sure that these digits are consecutive. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, we see 2 4-cell cages, which must add up to 10. So that must be 1 through 4. That means in the rest of box 1, the remaining digits are 5 through 9. To have 3 consecutive ones, either 5, 6, 7, 6, 7, 8, or 7, 8, 9. So this is 5. These are 5 through 9. This digit, which is in a 1-to-2 ratio with another digit, has to be 6 or 8. 5, 7, and 9 cannot be in a 1-to-2 ratio with another digit, because if you have 5, 7, and 9, you get 2.5, 3.5, and a 4.5. If you double 5, 7, and 9, you get 10, 14, and 18, none of which are digits. So this has to be 6 or 8, which is in a 1-to-2 ratio with 3 or 4 here. This digit, this is 5, 6, 7, or it cannot be 6, 7, 8 because that would eliminate all possibilities for this cell. So this is 5, 6, 7, or 7, 8, 9. Either way, then this has to be 5 or 9 here. Okay. These digits are in a 1-to-2 ratio. So we have 1, 2, 3, 4, 6, and 8. If we try to have 1 and 2 here, or 2 and 4 here, that does not work because that would eliminate 2 out of the possibilities of these 3 cells. And then these 3 cells would only have 2 possibilities each. And they would have 2 possibilities for all 3 of those cells. So that's not allowed. So this cannot be 1, 2. It cannot be 2, 4. So this has to be either 3, 6 or 4, 8. Which means with 3 or 4s here, that means this must be 1, 2, 3. Sorry, it must be guaranteed 1 and 2, and then the other one's 3 or 4 in this row. So that eliminates 1, 2, 3, 4 in the rest of the row, so that leaves 5 through 9 in the rest of the row. This cannot be 5, 7, and 9 for the reasons that we talked about. So this is 6 or 8 with 3 or 4. We have a guaranteed 6 and 8 here. That means this is 6 or 8. This is guaranteed 6 or 8. That eliminates 6 and 8 in the rest of the row because that's two cells which require 6 and 8. So this is 5, 7, or 9, which can be next to 4, 6, or 8 here. This cannot be 1 or 2. It has to be 3 or 4. Interesting. Four, 6, and 8, so it could be next to 3, 5, 7, or 9 here. Those are the only digits which are consecutive with 4, 6, and 8. What else do we have? 3 or 4 is consecutive with 2, 3, 4, 5. These digits here It could be 389, 479, 569, or 578. So this is 3 through 9, which means in the remaining digits in column 3, we have a 3 through 9 quintuple or septuplet, which eliminates 3 through 9 in the rest of the column. So this is 1 or 2, this is 1 or 2. Let's see. This is in a 1 to 2 ratio, so we have 1, 2, 3, 4, 6, and 8 as possibilities. Same here. 1, 2, 3, 4, 6, 8. Same here. 1, 2, 3, 4, 6, 8. And then 1, 2, 3, 4, 6, 8. We have a 1, 2, 3, 4 quadruplet in column 1. So that eliminates 1, 2, 3, 4 in the rest of the column. So these are 5 through 9. This cannot be 6 or 8 because of the 6, 8 pair in the box. This can't be 6, 8 or 3, 4 because of the 3, 4, 6, 8 quadruplet in the box. So we have 5, 7, 9 here, 5, 7, 9 here. Where are 1 and 2 in column 1? It has to be in these 3 cells, so this cannot be 1 or 2 here. So this is 3 or 4. Remaining digits in box 7 are 1, 2, 5, 7, 9. Interesting. This digit is the same as this digit. So then where is it in box 8? It's one of these 3. Obviously could be that digit. Let's start marking some 3, 4s. So this is 3 or 4. We're going to mark that as a different one. So this must be the blue one. This red one cannot be here, so this must be red here. It's one of these 2. And so blue has to be one of these 3 here. Red has to be one of these 3 here. These are the same digit. So... This is blue. Red cannot be here. This can't be 3, because if this were 3, that would force this to be 4, and they would eliminate all possibilities for that cell. So this cannot be 3. We have a 5, 7, 9 triplet in box 9, which eliminates 5, 7, 9 in the rest of the box. So this is 1, 2, 3, 4, 6, and 8. 1, 2, 3, 4, 6, and 8. We have a 1, 2, 3, 4, 6, 8 quintuplet, or not quintuplet, sextuplet in column 7, which eliminates 1 through 4, 6, and 8 in the rest of the column. So this is 5, 7, 9, 5, 7, 9. Okay. So again, the possibilities here are 3, 8, 9, 4, 7, 9. So that could work for any of those. 5, 6, 9. Or 5, 7, 8. So that's still pretty broad. This 3-4, 3-4 pair eliminates 3-4 in the rest of the row. Okay. You cannot have 8 here, because if you had an 8 here, that would have to be 4 there. You can't have 6 here because of the same reasoning. We have 5, 7, 9 here. What else do we have? Ugh. Red is one of these two. These digits are consecutive. Oh, this can't be 4 here. So, because it has to be 5, 6, 7, or 7, 8, 9. So this can't be 7 either. One of these two is 7 guaranteed. 4 cannot be any of these cells, so 4 has to be one of these 3. So this cannot be 4 here. These can't be a 4, 8 pair. So this is either 1, 2, or it's 3, 6 here. One of these is an 8. We don't know which. So if this is 8, this has to be 4, and then this is 2 and 8. If this is 8... Okay, so either this is 8 or this is 8 here. If this is 8, this is 4. That means 8 could be any of these. Ah, these pair of digits. So if this is 3, 6, obviously then this is 4, 8, and this is 3, 6. If this is 4, 8, this has to be 3, 6, which means this is 4, 8. So these are definitely red. So these are red. Right, so if this is 3, 6 again, this has to be a 4, 8 pair, which means this is 3, 6, so this matches that. If this is 4, 8, this has to be a 3, 6 pair, which means this is 4, 8, and again, this matches that. So these two digits have to necessarily match these cells. So this cannot be red. Red cannot be, is one of these 3. And one of those 3. Blue cannot... Okay, so this can't be blue or red, because this is red and that's blue. So this cannot be 3, which means this can't be 6. Um, red has to be one of these 6. It cannot be here, so red is one of these 4. And then it could be one of these 6. Where's red in row 2? Oh. Where's red in box 9? Sorry. I don't even know where I was thinking row 2. Red in box 9 cannot be any of these digits here because of the way that this we have these restrictions with this septuplet. So those are restricted, and because of how this works, this can never be 3 or 4. So red has to be one of these 2, which means this can't be red. So this can't be red and it can't be blue. This must be then a 1-2 pair, which eliminates 1 and 2 in the rest of the column. So this is red here, which means this can't be red because we have a 3-4, 3-4 pair in the column. So this can't be red. This is not 3 or 4. It's 1 or 2. Therefore, the red 3 or 4 also has to be here, which means one of these is 3 or 4. So it's either 3, 4 here or it's 4, 5, which means we have a guaranteed 4 here. This cannot be 4. This can't be 1 or 2. 6 or 8 is with 3 or 4. Because it can't be 1, 2 because of the 1, 2 pair in the box. So this is 6 or 8, which means it's with 3 or 4, which means that's with 6 or 8 there. This is 6 or 8 here. So we have a 6, 8, 6, 8 pair in box 9, so this becomes a 1, 2 pair, so this is consecutive with 1, 2, or 3, so this must be a 2 here, which means 2. This can't be a 1, 2 pair here. That means this is the blue 3, 4 to be in a 1 to 2 ratio, so this cannot be blue 3, 4. This is 1 or 2. This cannot be 1 or 2 here, because, again, if this is 1 and 2 as a pair, that would eliminate all possibilities for this cell. If it's 3 and 4, if it's 2 here with 3, that's not possible because we have a 3, 4 pair, 3, 4 being here, and a 3, 4 here, which eliminates 3 and 4 in the rest of the box. So this has to be 1 or 2, and this must be 5, 7, or 9 with 6 or 8. So let's match the reds together. So this is the red 6, 8. This is the red 6, 8. This is the blue 6, 8. So this must be 3, 4, 6, and 8 here, because there's no other possibility for the red 6, 8 in box 3. So this has to be 5, 7, and 9 remaining. So we have a guaranteed blue 6, 8 here. We have a guaranteed blue 6, 8 here, which means we have 2 blue 6, 8s in columns 2 and 3 guaranteed. So the rest of the column cannot contain 6 or 8. So this can't be 6 or 8 here. Therefore, the blue 6 or 8 is here somewhere. This has to be the red 6, 8 to be the odd, to be with the odd digit. This is red 3, 4, red 3, 4. Red 3, 4 cannot be here or here. This cannot be a 1, 2 pair because that would eliminate all possibilities for this cell. This could be the blue 3, 4, possibly. Red 3, 4 cannot be here, so this is blue potentially 3, 4. Red 3, 4 is one of those two. We don't know which one of these are the blue or the red 3, 6, 8 here. This can never be 3 and 8 Because if this is 3 and 8, that would force this to be 4 and 6, which is not in a 1 to 2 ratio with each other. So this cannot be 3 and 8. Could still be 5, 7, 8, potentially. Other possibilities. This 1, 2 pair eliminates 1 and 2 here. So it's just 5, 7, 9. So where are the 1, 2 pairs then? In row 9, it has to be here. So this is 1 and 2, 1 and 2. We have 1 and 2, 1 and 2, 1 and 2, 1 and 2, 1, 2, 3 here. Okay. We have a 5, 7, 9 triplet in column 8, which eliminates 5, 7, 9 in the rest of the column. So this is 1, 2, 3, 4, 6, and 8 here. Interesting. Hmm. These digits are the same. That's obvious. That's not helpful. Must match one of those two. That's obvious too. That's not helpful. Hmm. Oh, this still could be 8. I think I eliminated the 8. This because it could be 5, 7, and 8 here. Okay. Um. So this cannot be 4. It could be 3, 5, 7, or 9. There's no 6, 8 because of the 6, 8 pair here. Okay. This can't be 1. This is 5, 6, 7, 8, 9. So this digit must be the same as this digit. And it's one of these two, but we don't know which. Um. Oh. Oh no, this cannot be 8 because of the 6, 8. Yeah. We. Oh, it could be 8. We know the blue 6, 8's not here. Actually, the red 6, 8 can't be here either. So the blue 6, 8's here and then here. Red 6, 8 is here, so this can't be 6 or 8. So the red 6, 8 must be one of these two. These three, sorry. The blue 6, 8 is one of those three. Uh-huh. Hmm. So red 3, 4 is one of these 4. Uh, hmm. Um. Hmm. Ah, interesting. So again, this is 5, 6, 7, or 7, 8, 9. The other leftover 6 or 8 is here, and it has to be here, and it has to be here. Because of that, if this is 5, 6, 7, this becomes 8, and that's 9. So then this would have to be 8, 7, if that's the case. If this is 7, 8, 9, this is 6, and that's 5, but then this would have to be 6, so this would be 6 with 7, either way. So we're guaranteed one of this is 7, essentially, and this has to be 5 or 9. So 7 has to be one of these two then, because there's no other place for it in the box. So this cannot be 7 here, which means 7 has to be one of those two. Well, we have a guaranteed 7 in one of these two cells and a guaranteed 7 in one of these two cells. Where's the 7 in column 7? It has to be one of those two cells. Okay, I don't know what that tells us, but it tells us something. These digits could be 289, 379, 469, 478. Can it be 5? 568, yeah. Could be 568, but this would be 5 then if that's the case. Okay. Hmm. Um, hmm. 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 Huh. One thing we know is that whichever red is here cannot be in these cages. That doesn't tell us too much, unfortunately. Um, again, okay, so what are the possibilities? 2, 8. If you have 2 and 8 here, 2, 8, 9, that leaves this as 3 and 6, 1. So this would be 7. If you have 3, 7, 9, then you would have 4 and 8 here. And then this would have to be 6. So 2, 8, 9. Okay, 2, 8, 9. That forces this to be 3, 6. So this is 7, 1, 2. And this would be 4 and 8, I guess. Okay, so if this is 2, 8, that eliminates 8 here. So then this is 3, 6. This cannot be a 3, 6 pair. This is 2 and 8. That would force this to be 1, 2. So this would be not 2. It'd be 4 and 8. So if this is 2 and 8, this would have to be the 2. And this could not be 2. Because if this is 2 and that's 8, then this 4, 8 can't be a pair. It can't be 3, 6. It can't be 2, 4. So none of those are possible then, if that's the case. Here... we have 3, 7, 9. The 7 does not have to be here. The 7 could be here. Ugh. So we're guaranteed this is 4 and 8. Therefore, this would have to be 3 and 6. So the 3 could not be here. Because the 4 would be here. This would guarantee... Okay, so this is guaranteed... Okay. This is 3 or 4. This has to contain a 3 or 4 also, which eliminates 3 and 4 in the rest of the box. So this can't be 3 or 4. Therefore, this can never be 9. You either have 2, 8, 9, in which case this is 2. Oh, this can't be 5, 6, 8. If this is 5, 6, 8, that would eliminate all possibilities for that cell. So this is guaranteed 7 or 9. So you could this... Right. So again, if this is 2, 8, 9, that eliminates 8 here. So this is 3 and 6. This can no longer be 3, 6 as a pair. It's 4 guaranteed here. The 2 here would eliminate 2 here, so it's 1 and 2, which eliminates 2 here. So that'd be 4 and 8, which would force this to be 2, and that would be 8. So these are the possibilities. So 2, 8, and 9, 3, 7, 9, and again, because of this 3, 4 pair, this can never be 3 or 4. So this would be 3, 7, or 9. 4, 6, and 9, or 4, 7, 8. So if this is 4, this is 3, 6, and it cannot be 4, 6, and 9 then. Right, 4 and 6 would both have to be here. That would eliminate all that would force us to be 3 and 8, which is not in a 1 to 2 ratio. 4, 7, and 8 though does work because this is 4. This would be 7 and 8. So 4 and 8. So let's look at the possibilities for these cells then also. So if we have 2 and 8 here, this is 3 and 6. This has to be 3 and 6. So then this would be 7. And this would have to be 6. If this is 3, this is 4 and 8. So this is 4 and 8, which would make this 7 again, and this would be 8. So the red would be there both times, the high red. The 3, this would have to be 9 and 7. 4 would force this to be 3, 6. It would force this to be 3, 6. So this would have to be 6, and that would be 7. And then 5 does not work. So I think each case this is always the red low. Yes. 4, 7, and 8. So 3 would make this 4 and 8. That would make this 4 and 8, so this can't be 8 here. So this is always then, this is always the red. Because if it's 2, 8, this can't be 8, this is 3, 6, and that's 3, 6. So these are always the red. So this cannot be the red low. This must be the red low here. So this is not 5. This is red low. Whoops, not blue low, red low. We have all the, so this is blue high, which makes this red high. So this must match with this cell here, because this is the red digit, so 5 or 9, that matches with 6 or 8. So this must be the blue 6 or 9, 5 or 9. This is, again, the red 5 or 9. This is the blue 5 or 9. So blue 5 or 9, blue 5 or 9, which means one of these two is blue 5 or 9. This is 7. So that eliminates 7 in the rest of the column. That doesn't help. So this cannot be 7. Low red has to be one of these two. We don't know which. Oh, this is low. No, this is high red here. So that makes this not high red. So this is low red here. This is high red here. And then low red has to be here. Right? High red, high red, high red, high red. High red can't be here. So low blue has to be one of these two, right? This is guaranteed to be either 2, 4, 4, 8, or 3, 6. So we're guaranteed a 3 or 4 here. So that's low blue. Low blue cannot be here. It cannot be here. It's one of these 3, which is still pretty broad. Okay, low blue's here. Low blue's one of these two. Low blue's one of these two. Low blue could be one of these 3. High 6 or 8. We have 6, 8, 6, 8, 6, 8, 6, 8. So high 6, 8 cannot be here or here. It cannot be here. It has to be one of these two. So this is high 6, 8. High 6, 8 can't be here or here, so high 6, 8 is one of those two. That doesn't help us too much. High 6, 8. Red 6, 8 has to be one of those. High red, I guess you could call it, maybe. We are not guaranteed a 9 here. So this cannot contain high red 6-8 or the high 6-8. The high red or the low red. But so it cannot be 3 and 6 or cannot be 4 and 8. What are the possibilities? Again, you can't have 3, 8, and 9. 4, 7, 9 means red is 3. 5, 6, 9 means red is 4. You cannot have 5, 7, 8 means red is 3 and 6. I guess that's possible still. Mm-hmm. The 1s and 2s aren't helping very much. Uh, hmm. What am I missing? Yeah, maybe I would have to go through all the possibilities for 20. So this is the blue 5-9. This is the red one. One of these is the red one. One of these is the red one. So this is red 5-9, red 5-9. One of these three is red 5-9. Hmm. Oh, wait, this is... Doesn't... 7 can never be in the middle. So this is always 7 here, which eliminates 7 in the rest of the column. Ah, we have a 5-9, 5-9 pair now. There we go. This is 7 must be with 6 or 8, therefore this is the blue 6 or 8. Therefore this must be the blue 5-9. Since this is blue 6-8, okay, so therefore we have a 5-9, 5-9 pair. This is the blue 5-9. We have a 5-9, 5-9 pair in column 3, which eliminates 5 and 9 in the rest of the column. So this is 4. That makes this 3 and 6 and 3. This can't be 3, 4, or 6, so this is 8 and 4, which makes this 3 and 6. This is 3. This is 6. This is, so... This is 3. We have 6, 3, 3, 4, 3. 3 must be with 4, so this is the blue 4. The blue low. Therefore, this is not 3, this is 5 or 9. 3 is with 6, so this is 5, 7, which makes this 9. So this is 6, which makes this 8, which makes that 9. That makes this 5. This is 9. We have 4, 7, and 9 here, so this is 7. 3 is only consecutive with 2 or 4. This can't be 3 anymore. This can't be 3 or 6. It's 2. It's 4 with 2 or 8. So this is the low blue. This can't be 3. We have a 1, 2, 4 triplet. This is 3 and 6. We have 1, 2, 4 triplet, which eliminates 1, 2, and 4 in the rest of the row. So this becomes a 5, 9 pair. That means this cannot be 9. This is a 5, 7 pair. This is a 5, 7 pair. This 9 eliminates 9 here. This has to be 9. So none of this can't be 9. This is 7, which makes that 5. So this has to be 4, 7, and 8 then. 2 cannot be included. 3 can't be here. So this is 4, 7, and 8. Adding up to 19. This cannot be 8. This is a 2, 4 pair, which eliminates 2 and 4 in the rest of the column. So this is 1, that's 2. This 4 eliminates 4 here, so it's 2, which makes this 1, which makes this 2. So none of these can be 2. This is a 1, 4 pair. These can't be 6 again. This can't be 9, this can't be 9, and this can't be 9. Where's the 9 in box 8? It has to be here. So this is 9, which makes this 5, which makes that 9. That leaves this digit as an 8. This 4 eliminates 4 here, so it's 1 and 4, which means this can't be 1 here, so it's 2 and 1. This is obviously not the blue low, 3, 4, so that's the 4. This 7 eliminates 7 here, so it's 5, which makes this 7, which makes that 5. This 3 eliminates 3 here, so this becomes a 1, 2 pair. This obviously is not 3 or 6, it's 4 or 8. This can't be 8 because of the 8 in the row. This can't be 7 or 8 because of 7 and 8 in the row. This 5 eliminates 5 here, so it's 7, which eliminates 7 in the rest of this column. This can't be 5 because of 5 in the row. 1, 2, 1, 2 pair. This can't be 5 or 7, it's 6 or 8. 8 cannot be either of these cells, so where's the 8 in column 4? It must be here, so this is 8. This can't be 6 or 8, it cannot be 5, it's 7, which makes this 5. This is a 1, 2 pair. This 7 eliminates 7 here, so it's 5, and that's 7. Remaining digits in column 9 are 4, 8, and 9. 8 cannot be here because of 8 in the row. Remaining digits here are 6 and 9. In column 4. Remaining digit in column 5 is a 5, I believe. Yeah. This cannot be 3, 4, or 6. This can't be 3 or 6. Okay. This 5 eliminates 5 here. Where's the 5 in column 1? It has to be here. Remaining digits in column 2. We have 1, 2, 6, and 7. 7 cannot be here because 7 in the row. 7 can't be here because 7 in the row. Where's the 7 then? In column 2. It has to be here. So this is 7. This can't be 6 because of the 6 in the row. We have a 1, 2, 1, 2 pair in column 2, so this must be 6, which makes this 9, which makes that 6. 9 eliminates 9 here, so it's 4, which makes this not 4, so it's 2 and 4. This can't be 2 or 4, so it's 1, which makes this 2, which makes that 1, which makes that 2. Which makes this 1, which makes that 2. That eliminates 1 here, so it's 2 and 1. This can't be 1 or 2, so it's 8. This can't be 4 or 8, so it's 9. So 8 eliminates 8 here, so it's 9 and 8. That forces this to be a 1. And this is, of course, an 8. This 8 eliminates 8 here, so it's 4 and 8 there. And that's the solution. Interesting. Yeah, it was very interesting with all the 3, 4, 6, 8 combinations, and then the 5, 9 with the appropriate 6 and 8s here, right? Yeah, I don't know. It just seemed pretty cool. Nice puzzle. And then you had to go through all of these scenarios. That was interesting too. I don't know what else to say. Nice little puzzle. And I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.